Hey everyone, my name is Allison Ritterson-Lear, and I'm an engineer with Ceratec. Today we're going to be talking about hydraulic cylinders in NX Mechatronics Concept Designer. In one of our previous videos, we talked about defining your basic physics and joints and constraints in Mechatronics Concept Designer, or MCD. For this model, I've already set that up, but if you need to know how to do that, check out our previous video. I'm going to jump right in and start creating our cylinders. So I'll select the sliding joint that I want to apply the cylinder to. Take note of the values here. These are the starting pressures in each chamber. This is the piston rod type, so a single rod goes in one direction, and a double rod, which is our other option, can go in both directions. I've entered the piston diameter and rod diameter for these pistons, and the max piston stroke. I don't want them to actuate beyond 550 millimeters, otherwise the rods will pull out of the cylinders. And I'm going to create one for the other side as well. If you scroll down in our physics navigator, we can see that under sensors and actuators, we have our two hydraulic cylinders. Each cylinder requires a valve to operate. The valve lets fluid in and out of the cylinder as needed. I'll select the cylinder that should be paired with the valve, select the valve type. In this case, I want 4-way because I want my cylinders to actuate in and out. 3-way, it would only actuate in one direction. For my supply pressure, I'm going to give it 150 megapascals. Exhaust pressure, nominal pressure. Nominal flow is pretty important. If you make your flow too fast and your cylinder extends beyond the max extension that we defined in the previous step, then you might run into errors. Make sure your nominal flow rate makes sense. So now we have two hydraulic cylinders and two hydraulic valves for each of these cylinders. I'm going to go ahead and click play and we'll see what happens. So you can see the cylinders are extending, moving the bucket up. Once the cylinders reach their max extension, they stop extending, and that's it. The model doesn't move anymore. We need to add an operation to make the cylinders move in and out as we want them to. So I'm going to go up here to Operation, and this is going to operate on the valves, because really the valves are what control the cylinders. I'll select my valve. I want this operation to run for 5 seconds because it takes about 5 seconds for the cylinders to move completely in or completely out. And I'll select the parameters that I want this operation to control. In this case, I want it to control the control input. And I'll give it a descriptive name. The control input for the valve defines which direction the fluid is moving through the valve. If it's flowing into the valve, it's pushing the cylinder out, and the control input is 1. If the cylinder is retracting, the control input is -1, and fluid is flowing out of the valve. I'm going to go ahead and create the same operation for our second cylinder. For the inward motion, we might want to define this a little bit differently and instead define it based on the value that the valve currently has. So in this case, I'll make the same selection, but in this time, since we're moving the cylinder in, I'll enter -1. And this time, I'll also select a condition object. In this case, I'm going to select the same object, the valve, because I want this to actuate when the control input is 1. And I'll give this a descriptive name as well. And I'll go ahead and do the same thing for the second valve. And click OK. Now I'll come over here and click on the sequence editor. The sequence editor is how you see your different operations and how they are interacting in time. So you can see when I click play on this, all of these are going to try to run at the same time. And obviously they can't all be effective at once, so the model doesn't move. We can go ahead and change the start time for each of these. But first, let's do a little organization. I can go ahead and create groups for any operations that I want to group together. Select those two operations and move them to a group. I'll put those in group 1 and put these in group 2. So when I press play on the simulation, the cylinders extend because that's how I've set the control inputs on the valves by default. But after they've extended fully, I want them to retract. So I'll start this after 5 seconds. Then, after the cylinders retract, I want them to extend again. So I'll add a dependency between this operation and this operation. Now, after this in operation runs, the out operation will run immediately afterward. I'll do the same thing for our other cylinder and press play. And you can see that as before, our cylinders are extending. After 5 seconds, they start retracting, extending, and since we've set our retracting operation to be conditional, it'll continue to do this pretty much indefinitely. Thanks for watching. I hope you enjoyed the video. Again, check out our previous video on Mechatronics Concept Designer if you need any help with the earlier steps.